And of course, at the end of the session, please stick around. We usually go out for a bite to eat. We can talk more about any of the topics that we've heard about today. And Eugene and Stephen are in town for a few days, so it's a good chance to catch up with them. So stick around. Okay. You don't know my password? Okay. It goes to my head.
You got 5 post-it notes there, and you don't have your password.
Great. Okay. Now we need your presentation.
Thanks, Yvonne.
Okay.
After Shane's intro, I might just send my CV into the watch, but after what Richard was saying, PhDs being terrible,
I need to sign that.
I'm a bit scared now. Okay, anyway, as the thing says, I'm going to be talking a bit about what I use R for in my job at ANZ. It's going to be a bit of a sort of catch-all series of topics. I had to give a talk about R, and I was thinking, what the hell am I going to talk about? So I said, I'll just talk about some of the stuff I've been using R for. So just a quick rundown on some of the things I'm talking about. It's not actually going to be very sexy. There won't be any talk on like portfolio optimization or credit scoring or anything that might be a classic type of problem. But these are more of the, I guess, second order type problems that might pop up in the course of analysis that I do. So I'm just going to be talking about some of the projects that I've used R for, and maybe with some emphasis maybe on some of the syntax or some of the language tricks that I've used. Maybe people might be interested in them. And I'll also be touching a bit on SAS. You can't get away from SAS in a large company. And yeah, I guess I'll close some things.
Quick question. Assuming that ANZ have SAS in place, why do you use R? Is it functionality that doesn't exist, or?
I think that sort of deserves a very sort of long response. The short version, I guess, is that it's a more flexible tool than SAS, and it's easier for, say, prototyping or doing analyses a bit off the beaten path. SAS is good for, I guess, CAN analyses, production type jobs, data warehousing, data management, those kinds of things. But when you want to do interactive data analysis, when you want to fit a model that isn't exactly what ProcReg will do, it's a lot faster and I think a lot easier to do it in R than to battle with the SAS macro language or proc handling or anything like that. So that answer the question?
That's good.
Okay, so first thing I'm going to be talking about is this thing called a mortgage haircut model. So I guess I get to tell people I work with haircut models. Basically, as a background, when a mortgage defaults, the bank can take possession of the property to sell it and maybe make some of its money back. We have some idea of, say, the market value of the property. However, the price that the property goes for tends to be lower than the market value, and this is called a haircut. So the idea is that we sell it for some amount. If the sale price is more than what's owing, which is called the exposure at default, then we don't make a loss, meaning the bank. So the excess just gets passed back onto the customer. If the sale price is less than the exposure, then we do make a loss. And the problem is to figure out what an expected loss is. So you have some probability of default, you have some exposure, you have some probability that will be taken into possession, and then you have the actual shortfall at the end. So what I'm going to be talking about now is how do I get that last figure there, the estimated shortfall. Just a couple of notes as context for ANZ. About less than 10% of defaults actually result in possession. So this is not like the situation in the US, where I guess things are a lot more serious. The meaning of the haircut again, depends on context. US mortgages, haircuts mean something quite different. So you've heard about banks taking huge haircut losses. They actually actually talking about something quite different. Okay, so just to sort of demonstrate as a picture what I'm talking about, you've got a line there which is the valuation, so that's what you think the property is actually worth. The bell curve represents what the random sale price might be. This random distribution has some kind of expected value. The difference between an expected value and the valuation is a haircut. The red line is how much you actually owe. So the expected shortfall is just this bit down here. And from the statistical modeling point of view, what we want to do is basically find parameters for that sale price distribution. So we want to find out where the mean of this thing is, what the spread is. The stream distributional shape comes into it as well. And once you've found all of these parameters, then calculating the expected shortfall is just arithmetic. Well, it's complicated arithmetic, but it's just a matter of calculating it. So here are some graphs of a data set that I've been playing around with. These are actually about 600, 700 possessions. These graphs are for the same 700 possessions, but at different points in time. The y-axis is how much it's sold for at the end. So for any particular observation, let's say that one there, that is the same possession in all three cases. But the valuation differs. So this is the valuation when the loan was taken out. And there's obviously a lot of noise there, because when the loan was taken out and when it was possessed there could be several years passed between those two. This is what's called the curbside valuation. So after someone actually defaults, we send someone out to have a look at the property and basically check if the house is still standing. And after we've taken it into possession, then we'll actually go and have a look inside. Are the walls still intact? Is there crack on the floors, that kind of thing. So obviously, as you get closer to the actual sale point, the noise is going to get lower, and you're going to get a much tighter distribution around that 45-degree line. Just before I go on, any questions about that graph? Yeah, it's fairly clear, I guess. These are all on the log scale, by the way, so yeah, this actually represents a few orders of magnitude on the x-axis and the y-axis. Okay. So, talking about volatility, the sale price on the valuation is basically your haircut, and that appears to have systematically different volatilities for different types of defaults. So if we look at, say, property type, type A has got a certain standard deviation of 11.6 percentage points. For type B, it's a bit lower. For type C, it's a lot more. If you look at, say, state, I think for state 1, there was one default, so you can't get anything for that. But for the others, again, you've got some kind of varying volatilities. States 6 and 5, 6, and 7 seem to be fairly high, for example. So what I'm going to do is essentially just use regression to estimate that haircut as a function of loan characteristics. And you've got a hierarchy of models by complexity. You've got constant volatility, so you just assume constant standard deviation for every observation. You might have volatility varying by property type and state. And I'm going to use this log linear structure for the volatility to ensure that all my spreads are going to be going to have positive estimates coming out. So this is fairly basic, fairly standard, I guess. The constant volatility model is basically just linear regression. Varying volatility models can be fit using GLS in the NRMA package. But what I've actually done is I've just used Optim and NLMB to directly maximize the Gaussian likelihood. And if you recall, in the very first Melbourne talk, I don't know if many people were here for Andrew Robinson's talk. So he was actually talking about using something like Optim to maximize likelihoods, as an example of what we could use R for. Again, so conceptually, this is what I am trying to do. The red, the blue bell curve is your ordinary linear regression assumption. So you've got some kind of expected shortfall that comes about from that model. The red one is what happens when you have volatility varying, systematically. So in this particular example, you might see the spreads of contract around the expected value. In both cases, the estimated mean sale price is still fairly stable. But the problem is that I'm still assuming a Gaussian distribution for volatility, and the data can in fact be a lot more heavy-tailed than the Gaussian even after deleting outliers. So if I just go back to that this chart, if you look at this one on the right, I'm using the data that's in between those two sort of 45-degree lines to fit my model. So I've actually excluded these points. I think the lines are basically distance of plus or minus 1 on a log scale. So I'm taking anything that is within 2.8 times the valuation. Can I maybe express that a bit clearer? Does people understand what I mean? Okay. So I've excluded a few points which are way outside, but even in here, the distribution of points is fairly, is still fairly heavy-tailed or platykurtic. So there's more points close to that 45-degree line going through the origin, and there's more points at the extremes, and not so many points in the middle compared to a Gaussian distribution. So what I'm going to do is I'm going to replace the Gaussian distribution with a t distribution on some small degree of freedom. So the degrees of freedom acts as a shape parameter, controls how much influence these outlying observations will have on the result. And coding this is basically just a straightforward extension. I just replace all my normal distribution functions with t distribution functions. Nice thing about R is that I can still obtain the Gaussian model by setting my degrees of freedom to infinity. So here's, as mentioned before, this is all pretty much like what Andrew Robertson talked about a few months back. Here's, for example, the estimated, some example of impact we're talking about for a certain property type, a certain state, some valuation and some expected value, some exposure default. By changing my estimated volatility, I can get very different shortfall estimates coming out of my model. So going from 7,000 up to 29,000, for example. So my mean formula still stays the same. So in all cases, I'm just assuming some constant haircut on average. But the spread of each individual observation can vary depending on what's in this volatility formula. And if I use my T model, I can get different results again. So going from say 4,000 up to 10,000. The interesting thing here, though, I guess, is the range from top to bottom is much lower for the T model than for the Gaussian. And that's because my outlying cases have a lot less influence on the T model than on the Gaussian model. R code for an R talk. So this is the actual model fitting function that I've used, simplified out a bit. I don't know if it's a feature or a bug of R that half the code is basically just bookkeeping. Everything from here down to here is just getting it into a form that, going from my formula and data inputs into a matrix suitable for manipulation. But essentially, I have my response, which is my haircut. This is my T log likelihood function. I start off with the ordinary least squares fit. Starting parameters are taken directly from that. And I just use NLMB to minimize the the log likelihood as a function of these parameters. So here are a couple of example calls. So, haircut, the mean haircut is just a constant, or fitted as a constant, but with variance varying by property type and state, or mean haircut varying by property type and the variance varying by property type. So these are examples of how I might call a function. And again, graphically, here's what it's doing. Because it downweights outliers, the t-distribution is more concentrated in the center, and that's basically forced my expected shortfall to be lower than it was originally. Model checking, so normal model residuals. I've got the histogram of the residuals and a sort of superimpose what the assumed distribution should be. So for the normal model, it's pretty out of whack. For a T model, it looks much better. This is 5 degrees of freedom. I could probably get it better again if I went to, say, 4 degrees of freedom. So just some notes, comments, I guess. Why does using a heavy-tailed error distribution reduce the expected shortfall? So normally, when you use some kind of heavy-tailed distribution for these risk applications, you expect things to get worse, not better. Well, as was said, with a normal distribution, the volatility is overestimated, so the t-distribution corrects this. The extreme tails of the t are not so important because at the lower end, your sale price can't be negative, and at the higher end, well, if the sale price is more than you expected, then your exposure, well, that doesn't really matter either. But this is not a monotonic relationship, so at low enough thresholds, the tail will eventually make itself felt. So essentially that means once you get all the way out down here somewhere, the green line will eventually be higher than the blue and the red lines, but you've got to go really far up for that to happen. And an interesting thing is that with mortgages and mortgage defaults, you can actually sometimes get that far out, so that's more of a practical thing. And I guess it's interesting because in most regression situations, assuming sufficient data, you don't have to worry so much about these kinds of distributional assumptions. So with reasonable data, your central limit theorem comes into play, your inferences, your standard errors are still roughly correct, and you're not going to go too far wrong, even if it's slightly more heavy-tailed than normal. In this case, it is important, so changing your distributional assumptions changes the expected shortfall by big amounts. So that was my first example. Anyone have any questions on that? So this is the second time I've talked about this, and both times no one's asked any questions.
I've got a question. So,
Yeah.
so the result of this analysis was what?
The result of this analysis was a model that we could use to basically feed into our capital allocation formulas. So at the moment, we're basically redoing all of our, capital and provisioning type models. So this is something that hasn't been done before. Okay, I think at the moment they've got some fairly primitive, ad hoc models, which are basically take some constant haircut or something like that. But I think from a practical perspective, I think it shows up what are the important questions to ask when you're fitting these models. So the important question to ask in this case is, what does the distribution of your haircut observations look like? Normally when you're fitting things, the regression type models, which many people are familiar with, you don't have to worry so much about that. So this is a case where you do have to worry about that. And yeah, that's probably something that was not apparent when we started.
So is it when you say it's being used in some other models or to work out how much, what's
the potential impact?
Yeah, what's the liability, possible liability in the future? Is it the average that's coming out of these models that's more important, or getting something like a upper confidence limit?
Well, if you recall, going back to my formula right at the beginning, that thing there is basically what all of our, say, provisioning models work on. Now, those numbers that I put up, so 7,000, 30,000, 10,000, is basically that number times that number. So by changing your model, you can make your provision, double or half. So there's quite a big impact there, and I guess it's more important than usual to make sure you get it correct.
So my question was more, so that's expected, average.
Yep.
But if they want to ensure that they are protected,
Oh yeah. There's this concept called, I guess, the downturn LGD, the downturn loss given default. That is a separate issue. So this is basically just on the expected loss. How you get to a downturn figure is something else again.
okay.
That's more sort of to do, I guess, with regulatory type requirements. There are things that APRA expects us to do, and that, I guess, constrains what we can do somewhat, and that is less statistical kind of thing as a result.
So here the output from R was used directly to feed into another system.
Not directly, but we can talk about it later.
Okay.
But it was, of interest. So it was used as inputs for further work in getting it implemented.
Got another question.
Yep.
Where the variance is impossible, so where the variance is impossible, how do you know which factors to put into optimize?
That is, I guess, that's a model building question, and you would answer that the same way you would answer that question when it comes to how you put in factors into a regression model. This is essentially like a regression model by flow variance. But you can rely on the usual, some of this diagnostics, things like that, so residual variance, obviously your AIC, those kinds of things can help you there. This is a fairly simple data set actually, so only got, I think, 2 or 3 variables to play with, so it wasn't that big.
Do you expect your model to drift?
Sorry.
Do you expect your model to drift over time?
They probably will, but again, that's something that I haven't touched on yet. So this is all, I guess, foundational stuff that we're doing at the moment.
How do I convert to the normal LGD? How this model, convert to the normal LGD? You said the downtown LGD is not related to this model.
How do I go to a downturn?
Yeah, no, just normal LGD. So when we do the regular capital, we got 2 LGD. One is downtown LGD, the other is normal LGD.
Yep.
Just expected. So what sort of this model can apply to the normal LGD?
The downturn LGD is
Not downtown, it's normal.
okay.
You do the economic capital, just two LGD. One is downtown, the other is just normal LGD.
Yeah.
So is that normal LGD talking about?
This is that's right.
Yeah.
So this is basically just the expected value.
Yeah, it's not
It just gets plugged into economic capital because of that.
Yeah.
So banking shop talk. I'm not really a banker, by the way. So. All right.
One more question. I noticed in the any kind of regression analysis, you have the residuals on both positive and negative. So in some instances, the bank, I suppose, they talk about hair extensions rather than haircuts. So the valuation was, what they ended up ultimately getting was more than the valuation.
Oh, yeah. What happens if you get more than the valuation? That's fine. But basically, where was it? So, sorry, I was just trying to get that chart up again.
You passed it.
Yeah. It is possible to get a sale that went for more than you thought you'd get. That tends to be rare. But yes, that's possible. In the end, though, I guess what we're really interested in is whether or not something falls on this side of that red line. And yeah, that is basically the question of interest from a statistical point of view. Okay.
But according to the regression, the residuals are on both sides of the line, so there were some overestimates and underestimates.
Yeah.
What's the distribution is non-normal. I can see that there was a positive skew, but the tail, because it's positive, does it cancel out in the end? Do they really take a loss on average?
Okay, the thing is that this is fundamentally an asymmetric problem. Basically, if you get a really low sale price, then you have a problem because you take a loss. But if you get a really high sale price, then you, the bank, doesn't have a problem. You get all your money back and you can pay it back to them. Right?
I'm not a banker, but I think if you over-recover, you have to pay the money back to the
Yeah,
initial borrower, so you don't ever get a positive.
that's right. So as said before, so if the sale price is more than the exposure before, we just refund the excess.
Why are the valuations always higher than this? Tend to be always higher than the sale price? Are the valuers being optimistic?
That's, as I said, I'm not a banker, but these things tend to be, say, distress sale. So the bank's focus is basically just to get money back without spending too much time on the process. So it might not take as much care to get the best deal possible. People might know that it's not the bank is out to do that. They might play hardball. But these are, I guess, more problems for collections guys to worry about, and they assure me that yes, you do tend to take less than fair value.
You better move on, I think. You better move on.
Yes, that's right. Before I up ANZ even more into it.
No, I'm just getting hungry.
Oh. Okay. So yeah. Okay. So now I get to sledge SAS a little bit. SAS has prop mix for modeling variances. This is a mixed models type thing, but it only allows one grouping variable and assumes normal distribution, so it's not quite doing what I want to do. You can use proc endling to do general non-linear optimization. So if I wanted, I could take this thing and convert it into endling. And it probably wouldn't be that, this bit down here anyway, wouldn't look too different. But everything up here would be very different, because obviously endling doesn't have any concept of what a formula is, that kind of thing. And you can also do it in proc IML, and I will talk about IML later on. And none of these are as flexible or powerful as R, because R basically, the function returns an object, and you can do things with an object. You can get predictions, you can manipulate those predictions, get summaries, and so on. SAS 9.2 now actually does proc PLM, which does something like that. But again, only a few procs support PLM, and if you're fitting a custom model like this one is, then you can't really use that. So I guess this gets back to your question, why do I use R instead of SAS? Okay, second example, which is through the cycle calibration. Again, talking about capital. For capital purposes, we want an estimate of someone's default probability that doesn't depend on what the economy is currently like. You can call this through the cycle or long run PD. Contrast this with the point in time or spot PD, which is what most models give you. Models, all data is point in time, so models generally point in time as well. Exactly what long run means, it can be a bit complicated. I'm going to define it as just what the customer's average risk is, given their characteristics across all the different economic conditions that might arise. And in particular, no, this is not a lifetime estimate, for example. If you have, say, their age or their time on books, this doesn't change as you look at what this average risk is. Which variables are considered to be cyclical can be kind of tricky because things like credit card balance might go up and down depending on the cycle. And during bad economic times, the long run PD will be below the spot and vice versa. This is actually desirable. You don't want to have to raise capital during a crisis. The idea is that you should have raised the capital during the good times, so you don't have to then scramble for money when it's expensive. So, through the cycle approach, I'm going to start with my spot estimate. So I'll call this my PD as a function of X and E, where X is my individual customer's characteristics, and E stands for all my economic variables, which will be constant for all customers at any point in time. I think the technical name for this is a panel regression. Not that I know anything about panel regression. F, for example, might be a logistic regression, which everyone tends to use for better performance. Okay, and I'm going to average over all the possible values of E to get a through the cycle estimate. So here's a nice picture to sort of illustrate what I'm talking about. So over time, as the cycle goes, as the cycle moves along, someone's PD will go up and down, the risk if you like. If you were to average all of these points, you might get something like this. And your through the cycle PD is just what the average is of that distribution. Doing this graph took me like 2 hours an hour. That integration, this is basically some kind of integration over E, is complicated. You can do it in various ways, like Monte Carlo integration or something. I'm going to do take the simple approach of backcasting. I'm just going to take my historical values for E, substitute them into my prediction equation, and just take the average of the results. As we're interested in means rather than quantiles or other complicated functions, this hopefully shouldn't affect the result too much. Other practical issues will have much more impact. Things like how far back do you go, what variables do you use, how reliable is my data, those sorts of things. And I'm going to be using R to handle this whole backcasting thing, combining the multiple spot PDs into one value. And again, you could do this in SAS, but it would involve a lot of macro programming and manipulation of arrays. So here is my through the cycle calculator. My spot prediction is going to be just a simple function based on, I'm going to pull in my data, which is just a sample of customers. The code's just going to be directly copied from SAS. Conceptually, my linear predictor is some big logistic regression equation. This can be arbitrarily complex because the models themselves can be pretty big. The through the cycle prediction basically uses this, substitutes in different values of economic variables in here. So data is going to be whatever subset of my economic data is for a given point in time. I'm going to calculate my PD for that point in time, and I'm going to take the mean over different points in time. Hopefully everyone here knows what the apply thing does. Oh, okay, right. Apply is basically means in this case, I want to, given a sort of matrix-like object, in this case, PD is a matrix. I have one row for each observation, for each customer. I have one column for each point in time. I want to apply this function, the mean, across all of the different rows. So I'm going to take all of the values for each column, and average them. I'm going to do that for each row. The result of this is going to be a vector of predicted PDs, one for each observation. It's like doing a for loop, but in one line. It means you're very smart. Now the tricky thing is that this through the cycle estimate, which I've just obtained, is going to be a combination of many spot PDs, each of which is a logistic regression. So it's going to be pretty complicated. And if you were to give me, okay, this guy is say so many years old, has this particular address, has so much in terms of his balance or his credit limit or whatever, I could give you back what the estimated through the cycle PD was for him, but I couldn't easily tell you what the formula was that I used to get that prediction. So obviously I need to simplify it for communication and implementation. What I'm going to do is I'm going to actually turn this raw through the cycle estimate into bins. So I'm going to just cut my data set according to various attributes. I'm turning to a big contingency table. Everyone within each cell of this contingency table gets the same through the cycle estimate, just the average of everyone in that bin. and I'm going to take a very pragmatic approach. So I'm not going to be using anything like decision tree or regression or some machine learning type approach. I'm just going to create some tiers based on a small selection of variables to split out my riskiest customers, say my low doc loans or people with lots of bad comments on their bureau file, things like that. Within each tier, I'm going to create a contingency table using some attributes which the business considers most interesting or most important, because these things are going to be used for management purposes. They're going to use it to, I guess, monitor the results. So it has to be interpretable. It has to be, understandable to the business. And the number of cohorts is limited again by the fact it's got to be understandable. You want less than 1,000. Ideally, you want less than 100, but that's probably going a bit too far for accuracy purposes. And as I said, it's not a data-driven approach, although I am going to be looking at the data to help understand what's going on.
How do you know that? Must be less than 1,000, not 100.
Sorry?
How did you find out? Must be less than 1,000.
Well, you go to them, here's my wonderful set of cohorts. I have 1,800, and they go cross-eyed. And maybe a few. You need a few smaller number.
That's very heuristic. Very heuristic.
Yes. So here's an example of what I'm talking about. On the left side is a histogram of my through-the-cycle estimates for a portfolio. They range from, say, about 1% up to 10%. If I cohort this down to, I think, about 500 or 600 odd, I get something very similar. Obviously, as your number of cohorts goes down to 1, this thing sort of shrinks down to just one cell and gets like, 1 point. So the smaller the number of cohorts, the tighter the distribution on the right is going to be. So in this case, the distribution is still fairly broad, so I haven't lost too much information. Okay. So just an example of how I'm going to be doing this. Here is my starting input. So this is a list of the variables I'm using to define my cohorts. So I'm going to be using, say, low doc, yes or no. Number of, I think, inquiries on the bureau file, which can go up to like 50 or 100 or something like that, but most people are on 0 or 1. The loan to value ratio, so if you take out, I think it's at origination, so if you take out a mortgage, usually the bank says you can't take out more than 80% of the value. That's the LDR. By application of expand grid, I'm going to turn this into a set of cells. So low doc no, number of inquiries 0 or 1, 50 LDR or less. That's tier. It's one cell. Next cell down has LDR 60 and so on. It's actually by application of expand grid and a whole bunch of other stuff, but I thought it was too boring to put on the slide. This is what the actual output is going to be. So the output is actually SAS code for scoring the data set. Okay. First of all, I start with, from here, this basically defines my cut points for each continuous variable. So 0, 3, 10, 25. If that is, yeah, sorry, the cut points are 5, 15, whatever. So 5, 15, and so on. Cut points 60, 70, 80, 90, and so on. And having defined these sort of like bin values, this is the other result, which is basically just code for assigning a PD to each cell. So here is an example of using R code to generate SAS code. Okay, so this is a loop across all my tiers. So create tiers based on a small selection of variables. So I think I have 6 of them. Within each tier, I loop across all the variables that go into defining the contingency table for that tier. So I loop across all of these. and I just write it out. It's some SAS plumbing to sort of link it all together. And I think when I showed some of the people there that all it takes to create a text file is just the right lines function, so that, oh my god, it's that easy. So, okay, so any questions about that particular application?
Having come, done all the work in R, why wouldn't you just let R generate SQL code rather than SAS? Meaning, why have SAS in between it all?
Oh, it's just to do with how ANZ, I think, does its business processes. So a lot of this stuff is handled in SAS. So, historically they've used SAS code for doing all of this. So it's just fitting it in with the way it's usually done there. But yeah,
Okay, yeah.
I'm waiting for your example of SAS generating R code.
that's coming up next.
So I'm going to ask my question again. For this application, this is an example where R is used in your business.
Yes,
Correct.
yes, that's right.
So this is actually used.
Yeah.
Right.
And so this was actually for a fairly simple application. For the more recent one, which is a bit more complicated, so in here you can get models that have, say, something like DSR, which is your debt service ratio as a variable. Debt service ratio is essentially the amount of the repayment for a loan divided by your income. The repayment is a function of interest rate, and your income is a function of, say, the wages index. Because technically speaking, you only know the income when you apply for a loan, and then when you want to sort of update it, all you can really do is just update it according to what AWE or something like that might have done. So in here, I actually have to sort of break out the DSR calculation, update both bits, and stack them back together again. So this can, like I said, can get pretty complex. I don't want to do it in SAS. So the third example, so this is a stress testing simulation. So the background is that banks run stress tests on their loan portfolios to see what a downturn would do to their financial health. I think this is going on in Europe, for example, at the moment. They're testing all the banks to make sure that they're not going to fail their Greece defaults. Whether or not the stress test will tell you that is not a question, but that's what they say they're trying to do. The mathematical framework is kind of similar to this thing called a Vcasmo model, which I don't know if any people are familiar with. Good, I'm not familiar with it either, so. Basically, though, you represent the economy by a parameter x. Each loan has a transition matrix that is shifted based on x, determining its risk grade in a given year, given its risk grade in the previous year. And a loan defaults if it gets to the bottom grade. So, for example, Standard & Poor's has, I think, 10 or 12 different grades. The best is AAA. The worst is, I think, F or D or something. I'm going to take a scenario, a simulation-based approach. I'll set X to some stressed value. This shifts all of my transition matrices as an amount. I'll run, I'll basically take this through some Monte Carlo thing n times and basically get the average out of that. Contrast to value at risk. This is like saying the average result for a stressed economy as opposed to the stressed result for an average economy. Anyone here familiar with value at risk? Okay. VAR basically means you say simulate what happens to X, and then you take the quantile for the resulting distribution or outcomes, and you take a really high quantile, and that is your stress result. And for example, I might apply this to a portfolio of 100,000 commercial loans, along with, I've got the current risk rate as an input, split by sub-portfolio, and I'm going to be simulating this over 3 years or thereabouts. The application has its front end in Excel because everyone in the business world lives in Excel. I'm going to call SAS to set up the data sets, and SAS is going to call R to do the actual computations. I'm doing it because I can. The previous version was an ad hoc script written entirely in SAS, which took 4 hours to run, because basically it was written as a series of data steps, so it's very disk-bound. And the transition matrices themselves were represented as gigantic if-then-else blocks. So, yes, you had multiple 625-line blocks in there.
You weren't using IML?
Sorry?
You weren't using IML there?
Oh, this was done some time back, and they just never had a chance to really update it. They didn't have IML at the time. I got that down in 2 minutes. 1 megabyte of code cut to 10K. This is not rocket science. This is just using a tool that's better suited to the purpose. I could do something similar with IML, and I'll talk about it as well. So basically, what I want to do is for each sub-portfolio in here, I want to get the median result and store it, because for next year, I'm going to use this year's median result as the input. This is a kind of weird way of doing it, but that's basically, that was like a parameter. That's how it's supposed to be done now. To avoid having to store multiple copies of the portfolio, I'm going to manipulate random seeds. This is basically what it looks like as of semi-pseudocode. For each portfolio, for each year, get the seed, do it, I think, 1,000 times, get which of those 1,000 times was the median, and just store that particular thing as the input for the next year. This means, for example, I don't have to store 1,000 portfolios and get the median of those. Data structures, and I guess this is the interesting bit from an R point of view. For business reasons, as I said, we want to split the simulation by sub-portfolio and also present results for each year. So we have this kind of 2-dimensional matrix structure for the output. So the ij entry is going to be a result for the ith sub-portfolio, jth year. The desired output might itself be, fairly complicated, statistics, diagnostics, whatnot. So it has to be some kind of list, because that's what you use to store arbitrary input or arbitrary data. Similarly, we have a separate input transition matrix for each sub-portfolio and year. So the input needs to be a matrix of matrices, whatever that is. As it turns out, R allows matrices whose elements are lists. I'm sure some people here are already familiar with this, but maybe some aren't. So, on the input side, if I define T as a matrix of lists with these dimensions, I can basically store my transition matrices in this T structure such that it's going to be matrix for this year in sub-portfolio, matrix for the next year in sub-portfolio, and so on. Similarly, on the output side, I can say the component called result for M is going to be my transition result. I'm going to get some summary statistics and store it in that cell as well, but with different component name. So it's a good way to just organize things like that, which sort of mimics the actual structure of the program. And it's better than the alternatives, so like lists of lists. You don't get the ability to operate on all values for a given I or j. You could have separate matrices for each statistic of interest, but you're going to have a lot of variables to manage, and there's going to be no structure, so loops may involve some nasty sort of text mangling. So, for example, if I had one matrix for each of my sub-portfolio and year, if I wanted to loop through each sub-portfolio and so on, I would have to basically construct some way of getting the appropriate variable, which would be pretty ugly. And multi-dimensional arrays, you're going to be conflating. It's not really getting at what you're trying to do. It can lead to kind of weird code though, so you're not supposed to understand what it does. I have to look at it for a minute, to sort of remember, oh yes, that's what I was trying to do. So, from IML, as of SAS 9.2, you can use IML to execute R code and transfer data sets. So I'm going to basically use IML to do all that. I'm going to use IML to export a data set to R, which creates a data frame. I can basically send the name of my function script to R, name of my script file to R, and all of my various simulation parameters. So in R, I use SAS to call R. And that is basically, the bulk of the program. Of course, I'm not actually showing you this script itself. But the nice thing is that I no longer have to mess around with import, export, dealing with things like, messing dates up, and so on. Half the code in an earlier version was just for that. Yes, I get to sledge SAS up again. IML doesn't have a lot of things that you take for granted in R. So IML doesn't have watchable vectors. It doesn't have support for zero-length vectors. And you should kind of forget that they're very useful until you no longer have them. You don't have unoriented vectors, so basically everything is a matrix. So something as simple as that fails in 3 different ways. Okay. First off, Z is less than or in R is just logical. In SAS, that's a numeric vector with a whole bunch of 1s and 0s, so as soon as you try to index according to that, it falls over. You have to use something like, you have to use lock, the lock function to turn that into essentially, which we do in R. If there are no elements of Z which are less than 0, this indexing operation fails. So you have to check if lock Z is less than 0, is greater than 0, or something like that. Only then can you continue with whatever you're trying to do. And finally, if X is a row vector and Y is a column vector, then that also fails. So you check everything has the right orientation as well. So programming in IML is such fun. IML also lacks anything like a data set. Again, everything is a matrix. So ironically, it's actually easier to transfer a SAS data set to R than it is to IML. It has nothing like lists that allow lists of this, matrices of this. Everything is a matrix. Multi-way arrays, we keep in Fortran, seek and add, which kind of puts the occasional online grouching about R into perspective. So I think Rusty Haka and various other people have been saying R is too old and too slow and whatnot. So I guess I'm thinking, we have it really good. Don't worry too much. Some other SAS R interfaces that might be around. SAS has a proprietary dataset format. It has many proprietary dataset formats. R's foreign package has some functions to deal with them, but they're actually, I think, fairly old now and no one's really touched them for some time. HMISC has SAS.get. SAS7B that has a reader for that dataset format. Revolution R can read SAS datasets. All of these have glitches, not widely available, not fully functional yet. I've never actually been able to get SAS.get working. So if anyone has managed to get it working, please tell me what I'm doing wrong. The first two obviously need SAS installed as well. SAS 9.2 makes all of this moot. You just have to pay for it. But I'm working for a bank, they're paying for it, so I don't have to worry. Sorry?
And lots, not just little.
That's not my problem. Here's a caveat, it only works with R 2.11.1 because 2.12 changed the locations of the binaries. I'm sure some of you have run into this thing yourself. SAS 9.3 will support 2.12 then. Okay, so before I go on, does anyone have any questions about this example?
Okay. Sorry, what's the IML? Is it part of SAS?
It's part of SAS. It stands for Interactive Matrix Language. It's like it's the environment for doing matrix manipulation. So you can do things like matrix multiplication. You can do stuff like regression manually if you want, that kind of thing. It's a way of doing the kinds of stuff that you might use R for without having to leave SAS entirely.
So does IML talk to, sorry?
So I was just wondering if I buy SAS, sorry to everyone here, if I buy SAS 9.2, I always have IML, that
no.
will give me
You will have to pay extra for it.
extra, and that will give me ability to call whatever R code I have.
You will still need to have R installed. Obviously, you don't have to pay for that. Yes.
Yeah, we use a different method actually. We just, with base SAS, which is the cheapest one, we just do our normal stuff and then we just execute r.exe with a script that we have written. So in SAS, you write out a text file .sas with the code in it, which is what you did in the reverse. And then again in SAS, call the .exe with that as an argument. There are ways to do it. That's a lot cleaner than I'd actually prefer that to what you show for IML. Yeah.
So I've actually done that. So you can use something like I think a system command to call R script.exe with the R as an argument. This I guess handles all of that behind the scenes, but you can do that if you don't have IML. And obviously also with this one you don't have to worry about importing, exporting data, which is I guess another major thing. Okay, so talking about R and SAS, 15 minutes. Okay. We talk about the advantages of R, which I'm sure a lot of you are familiar with. It's free. Okay, it is, of course, a very powerful programming environment. SAS takes 3 languages to do what R does with 1. So SAS has, you've got a base SAS, you've got the macro language, and now you've got IML. There are 3 separate languages with interfaces to each other. Interfaces are where things get very messy. It is, of course, flexible and extensible, as most of us will be aware. It has lots of features if you can find them. User contributed packages are, of course, a big part of that, and they can be a problem sometimes. I'll talk about that later. And the ability to handle large data sets is improving all the time, just because computers are getting faster all the time. So if you can't handle 100,000 data sets now, wait 6 months, and you'll probably be able to do it, if you have a better computer. And I do fit models with like 100,000 data points routinely on a very moderate machine. If you had a top-end machine, I'm sure you can do millions, billions, or whatever.
Million data points with random forests.
There you go.
EPC.
2 variables there, Eugene?
About 30.
Yeah. Well, I work for a poorer bank. They can't afford to give me a really powerful computer.
But they can pay for SAS.
It's all gone on SAS, that's right. Advantages of SAS. It is a pervasive presence in large firms. And this is something you can't ignore.
How's that an advantage?
Okay, I'll get onto that.
Unfortunate realities is probably a better.
Yes. It is an advantage in the sense that all your processes are probably going to be built around SAS. Okay, so it's like if you have a choice of 2 tools to get a job done, all other things being equal, one tool fits in better with what other people around you are doing. That's a reason to choose that tool. Now, this obviously is not so important if you're not in that having to deal with existing processes. In the corporate world, you do often have to deal with that kind of situation. And they do give you long-term support and training and so on. So if you pay for it, SAS will give you a lot of hand-holding. And of course, it's very good for data warehousing and so on. People use SAS to do terabyte data warehouses, data processing and whatnot. So it's natural to then try and leverage that. Well, if I've got my data in this format, can I at least do simple analysis with it without having to go do something else? It has lots of features if you can afford them. So you pay for IML, you have to pay for SAS stat, you have to pay for SAS ETS, which is economic time series, SAS data mining, what's it called again?
Enterprise
Enterprise miner. So, you know.
That's not a feature, that's a problem.
Well, it does have features, but you know, you can do this.
It's an advantage to SAS, they make
It's
a
an
lot of
advantage
money.
to SAS.
Yeah.
And I will mention though, you know, SAS is sometimes cleaner than R, especially for data manipulation. I noticed that.
Sometimes, can you give an example?
Yes, but you know, before I'll mention that, you know, in places like Stack Overflow, you get a lot of questions like, I've got this data in this format, how do I mung it into some other format? You don't see quite so many questions when it comes to SAS, and I think, you know, that's just my observation. So here's an example. You want to get, say, just weighted summary statistics by groups. Very basic thing. If anyone's ever had to build a data cube, you know, you do this all the time. In SAS, that's what you do, and I think that even if someone was not very familiar with SAS or didn't know SAS, you would have at least a good idea of what you're trying to do. So you have some class variables, A and B, you have some analysis variables, X and Y, you have a weight, and you want to get the sum of the weights for each cell, you want to get average X, average Y, variance, and so on, and you want to put it to a data set. Well, that's fairly clean, you know, not too complicated. This is what it looks like in R. This took me a long time to sort of get into something that will not be too ugly. Okay. So this splits my data set according to my class variables. For each subset, I'm going to calculate the weighted mean and the weighted variance. So it's doing the same thing as SAS, but you know, it's doing it in a lot less transparent way, at least the way I've done it here. There are even more less transparent ways than this. This, I think, is as clean as I could get it. That's why you have packages like Flyer, and that will actually translate this into something that is a lot cleaner and looks much more like that. The problem is that Flyer, not everyone knows it's there. And not everyone will know that how to use it and so on. So challenges. This will, I guess, apply more to some people than to others, depending on where you're working and so on. Quality assurance or perception theorem. The core is great. No question about that. You know, in terms of numerics, I think R is better than SAS. So, you know, I've run into situations where SAS falls over because of some overflow somewhere, but R is fine. But of course, much of R's attraction is in its extensibility, so contributed packages. Can I be sure that the package I'm doing, does what it says? Is it doing more than it says? Is it phoning home? Is it going to be meddling with the stuff got installed? Backward compatibility, again, telling people to use the latest version is not always helpful. This is the standard, one of the standard replies on places like RHelp. Are you using the latest version? Remember, if I go back to here, sometimes I don't have the option of using the latest version. So no single point of contact. Who do I yell at things go wrong is how it usually ends up playing out. And again, how can I be sure everyone is using the same version? These are the sorts of problems or questions that get asked. On the more sort of technical side, Unix roots make package development clunky on Windows. So there's a line in the R frequently asked questions or R admin manual. If you're going to do this on Windows, follow these directions exactly, because otherwise things go wrong. That should not really be necessary, but that's because R is based on Unix. It uses the Unix way of looking at the world. So yeah, it's more fragile because of that. Why must I download things like a whole bunch of Unix command line utilities to compile code? It's difficult to integrate with, say, Visual C++, which is everywhere in the corporate world, Microsoft, yeah. Some really useful packages like, I think, inline just will not work with Visual C++, because R can't be compiled with Visual C++, basically. not without a whole lot of work. And yet interfacing with other languages besides just Fortran, C and so on, it's not really integrated. So you've got packages to do stuff like Java, interface with .NET and XML and so on, but they are again contributor packages. If say Duncan Temple Lang decides that the package XML is no longer interesting and he decides to do something else instead, you know, what happens in terms of maintenance? So, as an aside, you know, many of these issues are basically fundamental in nature. So, you know, R is not going to suddenly become Windows-centric just because I want it to be. And I guess that's where third parties like Revolution Analytics come in. I'm not a Rebel R user, I should mention. There were other R commercializations, I believe, but I can't find them anymore. S Plus is still around. Anyone remember S Plus? Yeah. Ross does. That's two of us. Okay. I guess here the challenge, I guess, is not to negate R's draw cards. So low cost is important. You know, it might be a $10 billion company, but the department that's going to be using R might have a $100,000 budget or something. The community and ecosystem, you know, can I use Rebel R with that package I got from CRAN? So if I use Rebel R, will I be welcome on R help, Stack Overflow, and so on? So sometimes, you know, people say, I'm using Rebel R, I've got this problem, and people will say, well, go and ask the people you bought it from, they should be helping you. Not very welcoming sometimes. And I guess, yeah, that's why SAS, SPSS can afford to do things like integrate R into their offerings and not worry too much they're going to lose customers. Okay, but again, you know, I guess these are good problems to have, you know, because they're a sign that R has moved into the mainstream. You know, S Plus now says it's R compatible rather than the other way around. Anyone remember these packages like Shazam, Glim, XList, stuff? Ross is too old. Yeah. No one cares about whether they support XML or C# or whatnot. The fact that people do care for R is, again, a sign that that's good. Okay, and I'm just going to close up right on time. Some other resources that I mentioned. There's a blog for SAS and R, which is like a companion for their book. That's pretty good if you're trying to, I guess, marry the two systems. There's Hadley Wickham's site, the guy who wrote ggplot, plyr, reshape, and a whole bunch of others. Stat 480 covers this in some detail. I don't think Hadley's a real SAS fan, by the way, but you probably knew that already. The do loop is the official SAS IML blog, so that actually is quite interesting, especially if you're trying to, say, translate R code into IML. Inside R's Revolution Analytics community site. There's the R bloggers aggregated blog roll. I should mention this one, Anne-Maria Dimars. I first found her site because she posted, you know, R sucks or something, and she got a whole bunch of R users blaming her. So, but that is actually quite an interesting blog, and I think she has quite a few good insights on like statistical analysis and the occasional rant on other topics. Okay, so I'll just leave it there if there's any other questions.
So can you go back one slide? Oh, one more. Can you answer that question? Can I use Rev R with that pack?
Well, as I said, you know, I'm not a Rev R user, but my understanding is that they are building it so that you can use any arbitrary package and it should just work. Okay.
Seems okay. I've only been using it for a few weeks, but I haven't managed to break it yet.
There you
With
go. Okay.
a good number of different packages.
So I tried installing RevOR, the community version, a couple of weeks back, so I actually used more than one core of my PC, and it failed to work. It was failing to work, which I think was because I had the most recent version of R. I think you needed to go back to something like 2.10 or earlier. And then I think the package I wanted to use from CRAN wanted to use a more recent version of R. So I think in that case, there's a
You probably ran into the fact again that the binaries live in different places from 212
They go to collection, kind of the back catalogue, so they can pick and choose.
You have to dig a bit to find the archives for early versions.
So how have you addressed these challenges of getting our used?
In a sense, I've gone around it rather than addressing it. Okay, I guess ANZ is, the people are fairly reasonable, and I think if you show that this is actually improving a lot, they are willing not so much to overlook the fact that these are problems, but just to live with it. And I think they accept that R is pretty much mainstream these days, and there are a lot of people using it, and it's pretty stable. It's not going to crash the network or anything like that. In terms of, say, single point of contact and so on, well, in theory that's a problem. In practice, most people never use, say, SAS anyway. So that's more of a, as I said, it's a perception thing rather than an actual thing. And I think what's happened is that if you go in, you use it, you show you're getting good results, people are not really going to complain too much.
So is it a case of you do some case studies behind their backs and then show them, look what I can do?
Yeah, pretty much. I did this analysis and got this result. Kind of thing.
But that's a real false sense of security.
It is.
Really. And it's demonstrated by one of, so those that don't know, Deloitte, one of our Canadian colleagues finding a fairly major problem with random forests.
Okay.
And they try to use it, and it's random forests have been used for ages, like the package in R. And to suddenly uncover something in a specific situation, which was only discovered when they decided, because Deloitte being Deloitte, risk averse, feeling a bit nervous about using an unvalidated software package, which is what R is. That's what you're talking about there. Validated packages, like the vendor supply packages. Decided to go delving in, checking, comparing against random forests in vendor packages, finding an issue, pretty obscure nonetheless, but the point is, for us, and Shane was talking about Deloitte's interest in R increasing, but a real stumbling block is the fact that it's not a validated package.
I think, and you're right, and there is the issue. You do run the risk that if things go wrong, people are going to start asking all kinds of questions. I guess I've tried to minimize the risk by sticking to the core as much as possible. So, I don't use stuff like Plier as much as possible. I don't use stuff that's done by some random academic to do some obscure task kind of thing. So all of the examples I've talked about here basically just use the core and nothing else. So you can try and minimize the risk going on, but yeah, you're right. As long as you're using stuff that isn't officially signed off, you do run that. That said, I think in practice people do tend to use a lot of stuff that isn't officially signed off, just because there is no alternative. So I guess it depends on who you're working with, I guess.
On that thing, it's almost quality assurance of perception is the core.
Yes.
Because we did some very serious automation in SAS when I was in Westpac. And when we were doing that serious automation, we came across in base SAS some really horrible problem, And it's base SAS, it's used by anyone and everyone. And there was really very little support from SAS to fix it, because SAS is not done here, it's in US, and most of the team here is sales team. And so it went back and forth. It took us 3 or 6 months to get some support to get it fixed, And so it's almost like it's only perception, because here you could put it in a user group and get a response much more quickly than what we got from SAS. But again, you never get fired for buying SAS, right? It has all these bugs that no one knows about.
And I used to work for a software vendor for about 7 years, and the stories, when you go to conferences and you talk to the SAS guys and the SPSS guys, the SPSS guys had doozies of stories about problems that would be uncovered by users, and they'd go for months without being addressed.
Yeah.
We have the problem with SPSS, so I just stopped using that function. We stopped.
Well, this
Well, I
was
think
something we couldn't
like,
avoid.
yeah,
I
they can't
think
get
that's
them
one of the
resolved.
things you don't realise unless you've like been on the inside of a vendor, is that this problem of something new comes out, does it work or not, I don't know, let's find out, let's try stuff and see how we break it. That's exactly what the vendors are doing too. So it's not like everything magically works when it's released. It's just that you don't see that that experimentation is furiously going on when you've only got one phone number to call and the community is all sitting in the same building or at least working for the same company. But none of these things get figured out except by trial and error.
How often are you in Sydney? And will you present to the Sydney users of our forum?
I'm actually in Sydney next week. Though.
Bit too soon. How about 2 months?
We can talk about that.
Excellent.
Okay.
Any more questions? It's getting late. Should we keep on going? No, have a good eat and drink. Thanks again, Hong, for a very interesting and engaging presentation. Looks like Sydney want you as well. Thanks. And if anyone who wants to come out for a drink or for a bite, please stick around. Okay.